Today's video will demonstrate how to characterize the level of understandability of code, as well as to improve the understandability of code. Hello, I'm James Helfrich. One of the largest costs of software is software maintenance. In other words, after the program is written, how much does it cost to maintain it, fix bugs, to support it, and add functionality? And a big factor of this is called understandability. For a given programmer, maybe you, maybe a coworker, maybe someone in the future, how much effort is going to take for them to understand the code? This video will demonstrate how to characterize understandability as well as to improve the understandability of code. Okay, so first, what is understandability? Understandability is a measure of how easy it is for a programmer to form a valid mental model of a segment of code. And there are several levels. The first one is obvious, and this is the best. We're open for this. And there is, quote, no room for confusion. There is, quote, no way anyone can misunderstand. And if you look at the code with that perspective, it's impossible for anyone to misunderstand this, then you probably have obvious. But of course, you'd be surprised. People always come along and say, hey, I didn't look at it this way. And you're like, oh, I guess your view is consistent, but it's not what I had in mind. We always strive for obvious, but it's impossible to prove obvious. The next is straightforward. There is no subtlety. Everything is clearly stated. We use all the usual standards, and there's nothing that's exceptional or clever. It should be possible to be straightforward, even if sometimes obvious is not possible. And that one level below that is deducible. All the information is present, nothing is missing, but you may have to use some cleverness or some insight or some intellect in order to be able to piece the clues together. Worse than that is misleading. And here we have something that is lying to you. It could be a variable, it could be a function name, it could be a comment. If there's anything that's lying or misleading, then is suggesting an invalid mental model. And the worst is puzzling. Substantial effort is required to figure it out. Normally, this happens when a programmer thinks they're being clever. Oh, look at how I did this. And they're trying to prove to their colleagues or even to themselves how clever they could be. As a result, the code is unnecessarily difficult to understand and sometimes not even possible to understand. We definitely don't want puzzling. To demonstrate how this works, let's take a look at some code. Okay, take a look at this very simple C++ program. What's going on here? What does this code even do? We can figure it out, but it will be quite difficult. While star tx plus equals star t plus plus, what's going on here? So here's a clue. This program will tell you whose turn it is in a game of tic-tac-toe. Now, I'm confident you could figure this out if you stared at it long enough, but really, what is going on here with this? So I think the programmer here is trying to be extra clever by making things unnecessarily difficult. That makes this definitely puzzling. So let's see if we can improve the code so it's a bit more understandable. Now, first of all, we have to realize that the first 9 elements here is my tic-tac-toe board, 3 by 3 by 3, right? And then we have a null character, which is going to tell us when we get to the end. And we're going to put the value here. Okay, that's what's going on here. So let's see if we could do something a little bit better here. Okay, let's take a look at what we did here. First of all, we turned our array of numbers into a 3 by 3 array. So now we have obvious rows and columns. And then we have a who won is going to be a separate variable that's going to return from compute rather than being put randomly in the 11th slot. And now our compute is going to go through my array, my rows and columns, and it's a 2-dimensional array. Is going to add the values up. If the values are greater than 0, is true, otherwise false. What's the level of understandability here? Well, we have a couple issues here. First of all, this computes whose turn it is, not who won. So my function comment is incorrect, and my variable name is correct. Next, we're going to go by row and column, but the columns and rows are mixed up. In other words, these variables are lies. So we have both problems with misleading understandability. Namely, we have variable names which are misleading, and we have comments which are misleading. Let's see if we can fix both of those. Okay, with this change, now it's more clear what this is doing. The function name is not lying anymore. The size of the array is not lying anymore. What's a row, what's a column is not lying anymore. So now we're no longer misleading. But the question is, how does this work? What does this even do? And it's really hard to tell here. And by looking at it, we really have no explanation. And so the answer is that we have to realize that if there's the same number of x's and o's, then it's x's turn. And so if x and o equals 0, then so this is x and this is o. And so if there's the same number of x's and o's, then it's x's turn. But if there's more x's, then it's o's turn. This was actually not only was it there we go, it was actually backwards. Okay, so but it's still kind of deducible, right? We want to make it straightforward. We want to make it clear how this is working. So we're going to try to make this a little bit better. So let's do some more refactoring. Okay, let's see what we did here. Now I've instead of using 1 and -1 for my x's and o's, now I have x's and o's, and it's a little more clear what's going on. So it's straightforward what each value stands for, at least. And now I've given it a proper variable name board, and my rows and columns are properly labeled. And if I have an x, number of x's increases, o number of o's increases, number of x equals number of o's, then it's o's turn, otherwise it's x's turn. So now it's completely clear. Actually, I think that's backwards again. If it's number of x's and o's, then it's x's turn, otherwise it's o's turn. Okay. Now, is there any possibility for someone to misunderstand this? And the answer is yes. The reason why is because we haven't explained why this works. And so if someone's going to make a change to the board or something like that, then they're not going to be able to probably fix this program correctly. So let's do one more hack at it, see if we can make it absolutely obvious. Okay, now what we've done here is we filled in comments describing what is going on each stage of the game. We have asserts as well to validate the board as to what we expect. So now there's no way someone could look at this code and misunderstand what it's trying to do, misunderstand the state of the board, understand the assumption of the state of the board, and understand how everything is being computed. This gives us obvious understandability. So as a review, puzzling is when almost extra effort was put in to make the code difficult to understand. Usually someone's trying to prove that they're clever. Misleading is when a variable name, a function name, a class name, or a comment is lying, is implying something other than the truth is there. Deducible is when all the information is present, but we haven't given anyone a clue as to how they go together. Straightforward is everything is clearly stated. There's no subtlety, but there can be further explanation because there are more than one way you can possibly understand something, and that ambiguity has not been rectified. And obvious is when there, and I need to air quote this, there is no room for confusion, that everything is completely clear how it works. This is the Characterize Understandability section of the Maintainability chapter of the software design textbook.